Okay, so in this video, I'd like to clarify the idea of horizontal transformation. Why is it that whenever you move, whenever you do horizontal translation, it does not follow the intuition? So an example would be, let's say I have a square root function like this. I have a square root function y equals the square root of x minus 4, for example. Or another one would be like y equals square root of x plus 4. Why is it that this one x minus y equals x minus 4 is moving to the left, whereas this one with x plus 4 is moving to this one is moving to the right. The x minus 4 is moving to the right. So I just fell into my own in my own error there because of intuition. But anyway, so this one will move to the left. The x plus 4 will move to the left, but the x minus 4 will move to the right. Okay, so in order to get the idea really clear, you have to think of transformation in two terms, as input and output. Okay, so whenever only the input is affected, like x is the input, here x is something is getting subtracted from x, here something is getting added to x, as compared to other types. Let me use another color over here. Another type will be if we had used y equals square root of x minus 4, and the other one y equals square root of x plus 4. So if you look at the blue ones, you will see that this first one right here, the x, the input is not affected at all. It's just by itself. So, but we have something being subtracted from y. So effectively, this negative 4 is affecting the y value, because think about it. If I plug in any x value, I will get some value for y. Then I subtract 4 from that value I got from the input, okay, from having evaluated the input. So here the same thing. To get y, I evaluate the input. I put 3 or whatever. I put 4. Square root of 4 is 2, for example. Then I add 4 to that value. So actually, effectively, I'm affecting the y. The output is getting transformed. So now that is clear, I hope it's clear the difference between input and output transformation. So now the next thing you need to understand is that if it's an input transformation like this first two, it will benefit you to think of it as actually moving the grid on which the graph is drawn. So to make that clear a little bit, what I'm trying to say is that if you think about this graph as being drawn on the grid, this is the grid. I'm clicking on the grid now. So the outside thing is the grid, okay, on which this graph is drawn. See, I can move this graph up and down. I'm moving the grid now. So I'm moving the grid. The graph is staying the same. You see, I'm moving the grid all up and down. That is the grid. Let me write because of my accent. So this is grid. I'm moving the grid, the x coordinate grid. All right. Or I can move the graph. So I can move the graph. So that's the inside one. I can move the graph. That's the y. So I'm moving the y now. That's y. So the grid the grid is the x. That's the on which the graph is drawn. That's the input. The grid is the input. So I'm moving the grid, and the graph itself is the output. Okay, the graph itself is the output. So now let me center this before we do the movement that we need to do. So I'm trying to center this. All right, I think it's centered enough. So now let's do the first input transformation. What I want to do is to move, subtract 4 from x. So what that means is that I am going to move the grid, which is the input. I'm going to move it to the left because I'm subtracting. I'm going to move it to the left. Watch what's happening as I move it to the left. This is 1 unit to the left. The grid is moving, not the graph. The grid is moving, not the graph. This is 2 units to the left, moving the grid. Okay. This is 3 units to the left, moving the grid. Let's go back. That's 3 units to the left. And now this is 4 units to the left, moving the grid. So you can see it appears as if the graph which is sort of like stationary all by itself, is now appear to have moved to 4 units to the right. So by moving the grid to the left, the graph appears to have moved to 4 units to the left, to the right. So effectively, whenever you do input change like that, this is a change of input 4 units to the right. Thank you. So then I can do the opposite. So let's move the grid back to where it was, back to the origin again. Okay, we're back to the origin. Now I want to do the other one now, x plus 4. So that means I'm adding 4 to all of the x values. I'm adding 4 to all of the x values. It means that I'm going to move the grid to the right, 4 units to the right. So I'm moving the grid now 4 units to the right. This is 1 unit to the right. Okay, this is 2 units to the right. Remember, I'm moving the grid on which the graph is drawn. This is 3 units to the right. Moving that grid, all right? This is 4 units to the right. Just the grid alone, okay? Now, the graph appears to have moved 4 units to the left because I'm moving the grid on which it is drawn, okay? So, so we say in transformation terms that this is a 4 unit movement to the right. This is 4 to the right, 4 right, because the grid has moved to the left. This one is 4 left, apparently 4 left. All right, so I want to move this back to, oops, I was going the other way. I want to move it back to where it was. So move the grid back to where it was. The grid is on the outside, okay? I'm moving it back to where it was. And it's back to where it was. So we have done horizontal movement by moving the grid. We are moving this grid on which is drawn. Now, we want to do vertical movement. Now we're going to do output movement. Output. Let's go to output. Output. Remember the output, I have to move the graph. So the graph is the, you see the outside layer, the outside boundary there, that's the graph. Okay, that's the graph itself, that's the output. So I want to move output 4 units down. So I'm going to move it down. So I just move it down. So it follows. The grid is stationary now. It's not moving. So you just move 4 units down. Right? So that's why this is 4 units down, because it's just the grid is stationary. This is 4 down. All right. Then let's get back to where it was, the original location. So I move the output back to 0, 0 over there, and then perform the other one. Okay, I want to perform the second one. Okay, now I will move the output. See, it says to move the output 4 units up. So I want to go 4 up. So I'm going to go 4 up. 4. I just move the graph for the graph, not the grid. 4 units up, and there it is. So graph has moved 4 units up. So that's why this is effectively 4 units up. Okay, so I hope this clarifies why it appears as if it's counterintuitive whenever you are moving left or right. It's because it's stationary. The output is stationary, but the input is moving to the left. The output appears to be moving to the right. All right, now I want to confirm this on Desmos for you to see. So here is Desmos. I do y equals, let's use quadratic, x minus 2, for example, and then squared. All right. See now, minus 2. All right, let's do the parent first of all. Let's do the parent. Let's just copy this and make the parent. This is the parent, x squared. Okay, that's the parent. If I replace, no, let's call it a blue here. Let's make it blue. Make it blue here. All right, done. Now, you see the parent is blue. That's the blue graph. If I replace x with x minus 2, you will see that actually the graph has moved. The red one is 2 units to the right of the blue one. See, it works. Now, if I replace that with x plus 2, let's replace it with x plus 2, you will see what's going to happen. Let's call this, let's make this grid green. Okay, let's make it green. Okay, so now if I replace it with x plus 2, you can see relative to the blue graph, the green is 2 to the left. So the green is the one that is moved to the left. So yeah, it is a little bit counterintuitive, but in reality, mathematically, it works. And that's how you can tell that it works. What if I replace this with the parent function by itself? That's the parent function. And then I move it to, I put minus 2 here. You can see it's going down. The red relative to the blue is going down. If I change it to plus 2, and then it's going up. See, the red one is going up relative to the blue one. So let's turn this green off so we only have that. So we can actually create, for fun, we can create a general form like this, where we have y equals parentheses x plus h. So h will be like a number that can change, right? And then squared, and then plus k. Okay, k will be a number that can also change. Okay, we're going to add that also. So add both of them as a slider. So let's turn everything else off. All right, now right now, let's say I have h as 0. Thank you. H is at 0. H is at 0. 0. Okay, and k is also at 0. All right, this is k at 0. So we have only one graph. That's the parent function. Okay, now I can move this h. This is the inside. I can move the input. I can change the input and move it to wherever I want and see how the graph is reacting to that. So if I move it to the right, see the graph is reacting by going. Let's change the color by going to the left. All right, let's react. Let's change the color. I'm sorry, and the color is changed to red. Okay, so this graph is reacting to when I move to the right, it's going to the left. All right, and if I move it back to 0 now, and then move the other one, when I change k, if I move to the right, it's going up. As k is positive, graph is going up. When k becomes negative, it's going down. All right, as opposed to the other one, see, it's going down. Hopefully this kind of clears it up for you that the left-right movement is counterintuitive, but the up-down movement is pretty much lines of what we expect it to be. Thanks for watching.